Yeah, this is going to be a short video about PLC evolution, and I'm going to use SIMATIC as an example, how the PLCs they have evolved. Again, SIMATIC evolution. I think this is a SIMATIC S3. We're going to look at that later on. Pre-PLC, a lot of relays. Relays for time delays, normal open close contacts, and so on. And they were huge and not easy to program, because program there was rewiring, and what they looked at is how could we make this rewiring in software. And Modicon, these guys here, they started out to make a Modicon controller, Modicon 084, with devices to control it and so on. So it's much easier. It has inputs and outputs, and the interconnection you make using software. And here you have some relay diagrams that you ladder diagrams, relay diagrams that you used as input to the program, how to wire this stuff. And unfortunately, these guys, they just continue using this the same technologies. They use ladder diagram to specify control. So it's 68. Maybe they could have looked at the Norwegian Computing Center, Ole Jakob Dahl. In this case, they worked on object-oriented programming, and maybe they could have made something that was better. Well, and we have with the ladder logic, it's still around. You know, it's combinatory logic, so it's difficult to make proper control with it, and it's even worse with FPD, the German way of programming the Siemens used. So okay, then we look at SIMATIC C1. What they made is that they use these chips here, 24-volt logic, DC logic. They had resistors and capacitors for time delays, and relay outputs, you know, and here are logic AND gates and OR gates and whatnot, and power supplies and timers. So special modules inserted in a rack, and then you did the program by wiring on the back of that rack. There were studs on the back of the rack that you can wrap wires on and make the connections between these modules. It was extremely robust. You will probably have to throw a bucket of salt water in here to make it stop working or set it on fire. And then they moved on to a programmable type, SIMATIC S3. I think this is SIMATIC S3. There's a link down here where I found this. With relays, I think the relays, I don't know what kind of modules there are, capacitors, what's on, or coils. Whatever, this is probably an I/O module of some sort. And after SIMATIC S3, they moved to SIMATIC S5, where they changed completely. And people used to SIMATIC S3, didn't like S5 so much, so Siemens got into problems. Which is, of course, bad for the next version, Siemens S7, because they didn't want to do the same mistake and make a completely new PLC and lose the customers, which they probably should have done. Yeah, whatever. There are SIMATIC S5 and more CPUs. CPU, this is S595U, 100U, 115U, 135U, and 155U. And the CPUs here is CPU 946, 947, worked as a pair. Later on, when they had to move into surface mount technology, because you couldn't get hold of these components, they made a new CPU called 948, which combined these two and was substantially faster, and so on. Slot for a memory module here, and so on. Yeah, I don't know if this is a CPU 947. I think it is. But it should be a memory module somewhere here too. Yes. So if you look at the rack, there's power supply on the left, and CPUs here, and I/O, and so on. And then you have the combined or compact with I/O and CPU and power and whatnot in one unit. So here are I/O modules. SIMATIC S5. So then they moved on to SIMATIC S7, and then they kept all the bad part from SIMATIC S5 and made some improvements for SIMATIC S7. most notably the engineering system and a high-level language programming language, structured text, or SCL, that was called by Siemens. So this is mid-90s, 95, 96. They made this S7 for 300 and 400. Is over here. There's 400, 300 here, and so on. Some ET systems and displays and program systems. And of course, it's still around in form PCS7. They made a new CPU, CPU 410, HF, hot standby, fail-safe CPU, which means you have two CPUs. If one fails, the one or other one is going to take over. There are some fiber optic cables connected for information exchange. And then they moved into something called S7 CPU, S7 1500 and 1200. This is the CPU one something. I think this is a 1516, 1517 with display on front, but they are basically programmed the same way as the old Simatic S7 system. But you have high-level language, SCL, structure control language, which is called. So this is how it evolved. And then Siemens also has soft PLCs. We look at soft PLCs. We have some from Codesys, a German company. I think this is a little more expensive. They even have a runtime for a Raspberry Pi and a system so you can control the Raspberry Pi as a PLC system. And then you have a German company again that makes hardware too. They are based on, now I think it's Windows 10 IoT operating system. Basically a PLC, a soft PLC, and running a special operating system and being programmed by really Codesys, but they have embedded Codesys into Visual Studio. So it's really good editor, really fast and good. And this system, I think they can run on here's a 12 core. I think it can execute on up to 32 cores. So it's a really powerful system, high quality hardware, and really fast. So that was the end of that. So this was an introduction on PLC evolution. I use Siemens for something, way back to relay, a lot of cabinets with a lot of relays, on-off delay relays, and so on. Simatic C1, which used 24 volts normal and or gates logic, not timing with RC circuits, and so on. And then there was Simatic S3, Simatic S5, Simatic S7, two types, 300, 400, and 1500, 1200. The later B is the new one. A little about soft PLCs. A soft PLC is a standard PC, IPC, a little robust PC running kind of a special operating system, or Windows IoT, some are using, and they are just being programmed